Alright, continuing on with these notes, here's part 2 of this is section 1.2 about graphs and lines. Writing equations of lines comes next. We've already looked at horizontal line. The equation looks like y equals a number. Remember, there's no x in this equation for a horizontal line. It's just y equals something. For a vertical line, there's no y in the equation. It's just x equals a number. Alright, you have to know which one is which, so make sure you keep those straight. Slope-intercept form, we've kind of seen this already. Let me highlight this because this is the normal form that you're used to when you talk about the equation of a line, y equals mx plus b. You call it slope-intercept form because m is your slope, b is your y-intercept. Point-slope form, actually, you can get around not learning this. You can really do everything with the y equals mx plus b, but I use point slope form quite a bit, and I'll show you two different ways to do these problems. I'll show you with using slope intercept form and with point slope form, and you can choose whichever method you want to use. This general form we will not use. You might see some problems start off this way, and I think they say you can write your answers that way, but I'd rather you write your answers in the slope-intercept form. I'll show you as we go through these examples. Alright, but all of these are different types of equations of a line. So let's first look at this first example. This first example is kind of silly. I think you do have ones like this in the homework, maybe one. But all it is, here it says find the equation of a line. They give you the slope. They will not always give you this, and they obviously won't always give you what the y-intercept is. Alright, but they just flat out give you your m and your b. All you have to do is write out the equation. Alright, y equals, the m is a -4 thirds. You got to put the x in there. That's that independent variable. Plus the b, and they flat out gave you what b was. Alright. Normally, you're going to have to do some work, like all the other examples I'm going to show you. But anyway, if they give you the m and they give you the b, all you have to do is plug those in. Alright, that's kind of a silly example. Alright, let's go to one where you have to do some work. And this next one, you do have to do some work. And I'm going to show you two different ways to do it. You guys choose the method that you want to use. Does not matter, and I'll show you we'll come up with the same equation. This example says find an equation of the line. Here they give us a slope, that's fine. It's -6, and it passes through this point, 3, 2. So I am actually partial to that point slope form. But again, I said you can get around not knowing this for now. Alright, the y minus y1 is equal to the slope times x minus x1. Where this comes from is just calculating a slope, because if you divide both sides by that x minus x1, there's calculating a slope right over there. That'd be equal to m. But anyway, this is point slope form. And what you do is you plug in, that's x1, this is y1, and this is the m that's given. So you just plug those in. Y minus a -2. Notice when I say minus a negative, I change it to plus. My slope is a -6. And I've got x minus 3. Alright, there's my x1, there's my y1. So here's my equation. You don't want to leave your answer in that form. You want to write your answer in slope-intercept form. That means the y is on the one side by itself. So let's distribute the -6 on the right, and then move this constant over, and we'll have our answer. So it'll be a +16 there. Alright? That's the answer. This is your equation. Our answer, we want it in slope-intercept form. That is one way to do it. Again, if you don't mind remembering the point-slope form, and most students want to do it this way, the y equals mx plus b. Everyone knows that form. Equation of a line. It's easy to remember. Everybody knows it. So, to use it this way, let me actually erase this x1 and y1. Alright. So, I happen to know an x that's related to the y. Those two are related. They're a point that lie on the line. And I know the slope. So when my y is -2, with the slope of -6, I know that the corresponding x is 3. That will let me solve for my y-intercept. You know, I can figure out what b is. I've got my x, and I've got my y, and I've got my m. So I plug all those in, and I'll be able to solve for b. All right, let's see what b is. This is at -18 plus b. All right, so to solve for b, I'd have to add 18 to both sides, so that means b is 16. This is the reason I don't like this method, because students will plug everything in and solve for b just perfectly, and then they'll circle b as their answer, which it clearly is not. Your answer has to be an equation of a line. So now you need to go ahead and write out your equation. Y equals the slope that we're using is -6x plus the b that you found. This is the answer, which totally matches this one. And you guys can use either method that you want. Most students prefer this second method over here. It's totally fine. Again, I'm partial to this one because your answer is automatically in an equation. All you have to do is just a little simplifying. Over here, yeah, you solve for b, but you have to remember to write out your answer correctly. Any method you want to use, show your work. Alright, let's try this again. Here, let's write the equation of the line. But they don't give us a slope, they just give us these 2 points. But, you know, we can find a slope given 2 points. Let's go ahead and calculate. Let's find that slope first. Remember to subtract your y's on top, so I'm going to take 2 minus 6 on top. Notice I started with this y minus this one. So then down below I have to start with the -4 minus a -3. So I'm adding 3 down below. Alright, I'm getting a +4 slope on that one. -4 over -1 will give you a +4 slope. I think I left some room down here to finish this up. Down below. But at this point, yeah, I'm going to finish it actually down here. At this point, you can do one of really 4 different things. You can use this slope with this point, and you can use the point slope form that I like. Or you can use the slope and this point and use point slope form. You still get the same equation. Now, if you don't like point slope form, you can use the slope intercept form, the y equals mx plus b. Use this slope and this point. Or you can use this slope and this point. Alright, so there's a bunch of different ways that you can do this problem. 4 different ways, still come out with the same answer. I will use the y minus y1 is equal to my slope times x minus x1. And I'm going to go ahead and use the -4 and the 2. Doesn't matter. Okay, whoops. Yeah, let's plug this in. What was my slope? Was a +4, right? Yeah. Alright, so let's do y minus 2 is equal to my slope. Came out to be 4x minus a -4. Remember, when you're subtracting a negative, that's +4. Let's distribute the 4 and add the 2. 4x plus 18, that's what you should get. And you come up with the exact same thing there, and I'll actually show you. Let's use the other point, the -3 and the 6, and let's use the y equals mx plus b. Obviously, you don't have to do it 2 different ways. I'm just showing you we're going to come up with the same thing. I'm going to use a different point and a different equation, and I'll end up in the exact same spot. Alright, this y is 6. My slope we calculated to be 4. My the x is a -3, looking for b. This was y, this is m, this is x. Alright, solving for b. You're going to get b is 18 when you add 12 over there. So then don't forget, you have to write out your equation. Y equals, we found the slope to be 4x plus the b that we found. Same answer. Whichever method you guys use on your test, show your work. You'll be fine. That way, if you didn't quite get the answer, I can see, if you just made a little sign error somewhere, but you knew, pretty much what you're doing, you're going to get a bunch of points for this. You'll just miss maybe only 1 point for making a silly sign error somewhere. So on all your tests, it's so important to show your work so I can give you some partial credit. Alright, that's about 10 minutes, almost going on 11. Let me do a couple other things and then I'll do part 3. Here, parallel and perpendicular lines and slopes. Whenever we talk about writing equations of lines, the next progression is to talk about parallel perpendicular lines, how their slopes are related. With the parallel lines, let me draw a little picture. X. Alright, I'm claiming L1 and L2 are parallel lines. So, since the slope is a number which represents like how slanted a line is, that's what a slope is, the rate of change of a line. If they're slanted in the same direction, that means their slopes are equal. That means M1 equals M2. The slope of line 1 is the exact same number as the slope of line 2. Those are for parallel lines. Now for perpendicular, it says these slopes are opposite reciprocals. Let me draw a picture. Besides vertical and horizontal lines, these are non-vertical or non-horizontal lines. Perpendicular. There you go. Alright, L1 and L2 here are drawn perpendicular. They intersect at a right angle. That's what perpendicular means. So their slopes are opposite reciprocals. That means M1 is equal to the opposite reciprocal of M2. You got to flip it over and take the opposite of it. Some books would say M1 times M2 is equal to a -1. It's seeing the exact same thing. Alright, but these slopes are opposite reciprocals. Remember, the opposite of plus is minus, and the opposite of minus is plus. But the reciprocal of a number means that you flip it over. You flip it over. Let's talk about opposite reciprocals for a minute. And I do just have a couple minutes left. Alright, I'm going to jot down some M1s, then we're going to practice with this opposite reciprocal. Let's look at -2, let's do 3/4, -1/5, and then 0.1. Okay. I'm looking at perpendicular slopes. M1 is the given slope, and what I'm trying to write over here, a column of opposite reciprocals. So, if I start with a -2, opposite of negative is positive, the reciprocal of 2, because this is the same as 2 over 1, is going to be 1/2. So this one's negative, that one's positive. If you flip 2 over, it becomes 1/2. Opposite reciprocal. Okay, here's 3/4. That one's easy. Opposite would be negative. The reciprocal 4/3. Got to do both. Take the opposite sign and flip that number over. Alright, a -1/5. Its opposite reciprocal would be positive. 5 over 1. Let's just write 5. This one was negative. This one's positive. Alright, a 0.1. Alright, that's the same as 1/10. Maybe it's a little easier to see if you write it as a fraction 1/10. Its opposite reciprocal would be a -10, right? 10 over 1, the same as 10. Okay, so opposite reciprocals. You have to be able to do that. Because what we're going to be doing next are writing equations of lines. And they might be perpendicular to a given line or parallel to a given line. So you have to be able to recognize what those slopes are going to be.